Electrochemical cells use chemical reactions to produce electricity by creating a potential difference between two different electrodes immersed in an electrolyte and allowing electrons to flow when the circuit is completed. A simple cell contains two different materials that have different tendencies to lose electrons, and an ionic solution or paste that conducts ions, so oxidation occurs at one electrode and reduction occurs at the other. During discharge, electrons leave the negative electrode, travel through the external wire to do useful work, and enter the positive electrode, while ions in the electrolyte move to balance charge and complete the circuit internally. The voltage of a cell mainly depends on the difference in reactivity or electrode potential between the two electrode materials, so a larger difference gives a larger potential difference. The electrolyte also affects the voltage because ion type, concentration, and temperature change the ease of the redox reactions and alter internal resistance. The size and surface area of the electrodes and the internal resistance of the cell influence the current delivered and the observed terminal potential, especially as the cell runs down. Cells connected in series form a battery whose voltages add, so three identical cells, each of 1.5 volts, give a total of 4.5 volts. Non-rechargeable or primary cells rely on reactions that proceed only in one direction, and they eventually stop when a reactant is used up. Rechargeable or secondary cells use reactions that are reversible, so an external direct current can drive electrons back through the cell and regenerate the active materials. In a typical cell under discharge, the negative electrode is the anode, where oxidation happens, and the positive electrode is the cathode, where reduction happens and electrons move from anode to cathode through the wire. A simple classroom investigation compares metal pairs such as zinc and copper or iron and copper in the same electrolyte and measures the open circuit voltage to show that a bigger reactivity difference gives a higher reading. Safety guidance includes avoiding short circuits, keeping cells the right way round, never mixing or charging non-rechargeable cells, and recycling used batteries responsibly. The key idea is that cells convert chemical energy into electrical energy through paired redox reactions at two different electrodes, and the voltage produced depends on the electrode materials, the electrolyte, and the conditions. While batteries combine cells and rechargeable cells can be driven backwards to restore their chemistry.